Good morning, everyone, and thank you so much for coming and attending via Zoom. Florida's way of water. What I'm trying to evoke, in spite of the parallel with the latest Avatar movie, or perhaps because of it, is that Florida, like the people in that Avatar movie, are dependent on water. We sometimes don't realize that when we turn on the tap, there it is. It's highly reliable, it's delivered in quality and safety, but we don't know, a lot of us, even where it comes from. So this is an effort to help people understand the critical nature of our water supply and what has and has not been done to sustain it. William Bartram explored Florida in the late 1770s and wrote his Bartram's Travels, which was extremely popular when it was found. The Europeans were fascinated with his descriptions of the wildlife and the springs, our beautiful first magnitude springs. Samuel Taylor Coleridge, whom many of us know of, and I hear an echo. Is it just me? It's just me, okay. Samuel Taylor Coleridge, the English poet, whose life overlapped somewhat with William Bartram, was one of those who found Bartram's Travels description as fascinating. And in fact, perhaps in an opium dream, he wrote the following. In Xanadu did Kubla Khan a stately pleasure dome decree, where Alph the sacred river ran through cavernless, measureless to man, down to a sunless sea. So twice 5 miles of fertile ground with walls and towers were girdled round, and there were gardens bright with sinuous rills, where blossomed many an incense-bearing tree, and here were forests ancient as the hills, enfolding sunny spots of greenery. Does that describe Florida? Yes, it does. And in fact, he's thought to have been responding specifically to Bartram's description of the Blue Springs near DeLand as it existed in 1775. There are 33 first magnitude springs in North Florida. That is, springs that flow at 100 cubic feet per second or more. Unfortunately, some of them have actually dried up. Others, just in the last 30 years, are no longer swimmable because of the nutrients in the groundwater and the algae that's growing. To me, that's tragic because I remember what it looked like even just 33 years ago. So I am delighted to introduce the first of our 6 speakers this morning, Jim Gross, the Executive Director of Florida Defenders of the Environment. Jim has been the Executive Director of FDE since 2016. He has considerable expertise as a professional geologist with 36 years of experience in water resources and more than 28 years of experience in long-term regional water supply planning, including at the South Florida Water Management District and with the St. Johns River Water Management District. Early in his career, after earning a BS in geology at University of California at Santa Barbara, Jim worked in geothermal energy exploration and development. He took a master's in geology at New Mexico State University and is a licensed professional geologist in Florida as well as California. As the director of FDE since 2016, Jim leads an effective and enduring watchdog group that seeks to protect Florida's water and water environments, and to ensure that state and regional governmental agencies follow science and the law. FDE's principal objective since the organization's founding by Marjorie Harris Carr in 1969 has been eliminating the Rodman Dam and restoring the Ocklawaha River and its springs. FDE funds research and litigation to protect freshwater resources, conserve public lands, and provide quality environmental education. So I welcome Mr. Gross.
Thank you. Sounds like I'm on. Okay. An introduction to the geology and hydrology of Florida Springs. This is a talk that I created some years ago. So not everything in it is totally up to speed, up to date that is, but it's fairly close. Yeah, there we go. Back, forward. Okay. It's always good when we're going to talk about springs to kind of look at them a bit and see what they look like. So I, by courtesy of my friend John Moran, who for many years worked for the Gainesville Sun, I have quite a few of his slides he donated to me for talks that I give, and also just for my lectures for my students at Santa Fe College. Oops, going back forward. Clear water and that blue color that we associate with springs. When we think blasted the slides off. We were one back from that one. Oh, I can take it back. Or you can. I want to go to the blue planet. There we go. When we think about the Earth, particularly when we look at pictures of the Earth as a whole, we tend to think of it as the planet with water on it. And indeed, if we compare the Earth to any other planet in our solar system, we do have quite a bit of water here on our planet, and it does dominate the surface. But there's another way to look at it. This is a slide that was prepared by the United States Geological Survey, and it rolls all the water off the planet and into three blue balls that summarize what water we have where on the planet. So this big blue ball here is all water on Earth. Now this medium-sized one, that's all liquid fresh water on Earth, liquid fresh water. So it doesn't include the ice on Antarctica and Greenland and in alpine glaciers. And this teeny little ball that some of you may not even be able to see floating over Georgia is all fresh water in lakes and rivers across the entirety of the planet. We're dealing with a finite resource wherever scale you look at it on. Sometimes the state of Florida has not treated its resource as being finite. Here's what we're going to talk about today. These 5 questions. Why do we have springs in Florida? Not just, springs, but why do we have a lot of springs in Florida? Where are they located on the landscape? Because they're not everywhere. Why does spring flow vary over the short term? And also, why is spring flow declining over the long term? And finally, why is spring water quality deteriorating? We kind of already heard a little bit about that, and I don't think that's anything you might not have heard of before. Take a look at this, see what the colors look like. This one's a little hard to see. It's kind of washed out, but it shows the extent of the Florida aquifer system, which basically goes up to about here, right? And but the extent of the Florida aquifer system where it's productive is more this blue line here. So it's a multi-state aquifer system, essentially all of Florida, and then parts of Georgia and Alabama as well. It's relatively thick. And the farther south you go, the thicker this aquifer system goes. Now you might be thinking, why are you calling it an aquifer system, Jim? What's that? An aquifer system is nothing more complicated than 2 or more aquifers that are connected to each other somewhat. And that's what we have with the Floridan. There's an upper Floridan aquifer and a lower Floridan aquifer. Most of the fresh water is in the upper. And we can see the thicknesses here. In some cases in South Florida, over 3,000 feet thick. And you might wonder, well, why does it vary so much in thickness? Well, it turns out that the rocks that make up this Floridan aquifer system, and they're carbonate rocks, calcium carbonate or limestone, they were laid down over many, many millions of years, and with a subsiding portion of the earth that kept getting built up with more and more carbonate. As it subsided, it filled up with carbonate rocks. So in South Florida, it's as much as 3,000 feet or even a little thicker in South Florida. But not much fresh water down there. Pretty salty, even in the upper Florida. So what is a spring? We can think of it as a very simple system, analogous to a tank of water, a hose that leads to a discharge point. The recharge area is where water comes onto the Earth's surface, percolates down below the Earth's surface, escapes evapotranspiration, and gets added to the aquifer system itself. That's our tank. Then there, of course, there's a discharge point, which is the spring. And in between, there is what we call a confined aquifer, which here I'm representing as a hose, meaning the water actually doesn't really escape that hose or that aquifer from the recharge area till it gets to the spring itself. So that's in the simplest case what it is. All right, why do we have springs in Florida? Well, these two things are the essential ingredients. We have high rainfall, not skyrocket rainfall, but compared to most of the United States, unless you're up in Seattle, it's high rainfall. And, you know, so that's the big part of it. And then very permeable rocks. That's essential. Here's mean annual precipitation across North America. And we can see that Florida is in sort of this lighter or medium shade of green here. So in the over 50 inches a year. So, you know, we get a fair amount. But, you know, you can see out west, it's much drier. Anybody's been out there or lived out there or visited knows it's dry. So we're in that moist area on the east part of the continent. And here's another representation of it showing that the details and how much more rain actually falls up in the Cascades and the coastal mountains up in Oregon and Washington. It kind of rains year-round up there. If anybody's lived up in Portland or up in Seattle, you know, you get used to clouds pretty much. So, but again, we're still, you know, in that intermediate range of blue here, in that 50 to 60 range. So we get ample rainfall for our springs. Takes permeable rocks for the springs to flow. So we have limestone, and limestone with solutional openings, which is what mostly we have, is the most permeable here. Now notice the scale is a log scale. So every time you go up, 10 to the negative 6, 10 to the negative 5, 10 to the negative 4. So it's going up by an order of magnitude each time there's a click there. If we're looking just at limestone without solutional, it's more moderate. But that's not so much what we have with in the portions of the aquifer where the water's flowing. It's much more like in this range up here. Now, the U.S. Geological Survey has done tests on the Florida aquifer system, on the rocks they get, from two different ways they've done it. They've done it with tests downhole by pumping the aquifer, and those are called packer tests. Packer tests, where they can pack off a portion of the borehole and pump just that section, measure how much water is coming out, how much the drawdown is, and they can calculate how permeable the rocks are. But they've also done core analysis, which is to say they've taken cores of the rock itself, brought them back to the surface, and they test them in the laboratory for their permeability. So we have two different ways we can actually look at this and determine how permeable the Florida aquifer system is overall. So where are they? Well, once again, they are where our recharge area, water coming in, is near a discharge area. And the discharge area is unconfined. Okay, so it's not a place where there's just sort of diffuse upward leakage. There's like a pipe coming out of the ground. That's what the springs are like. Here is a map that the Florida Geological Survey put together. It's not real recent, but it's still representative. And the blue dots are springs that the Florida Geological Survey actually visited and took samples from them and whatnot. And then there are other springs that they got from other people, probably USGS and some of the water management districts, to get data on the ones that are in yellow from the springs database. And you can kind of see the county boundaries here, but it's a little tough to see in this particular slide. This map represents what the United States Geological Survey believed was the flow into and out of the Florida aquifer system before it was developed. So they're estimating this like at around 1880. The first wells were not really significant amount of wells in Florida. Didn't really come along until the 1890s, largely because rotary drilling had not really been developed yet. They used to use what was called hammer drilling. Bang, bang, bang. It might take 3 months, 6 months. Might take longer to drill some of these wells, whereas a modern day rotary drilling rig drill a well and sometimes in a day or two, depending how deep it is. So, but anyway, this was their estimates of what the recharge was in inches per year, different shades of colors, up to in that 15 to 20 inches per year, which you can see tends to be more closer to the center of the peninsula. And then the discharge down here in these colors here. So there's really these dark black areas near our coastal areas because there's a lot of discharge to springs and diffuse upward leakage in those areas too as well. So those are natural discharge areas. All right, why am I showing you elevations? I'm showing you the elevations here in what's called a digital elevation model. So the light shades are higher elevations, and the dark shades are lower elevations going all the way down to the coastline. Of course, the Florida Keys are all lower elevations, all South Florida low elevations, and all coastal areas are low elevations all the way down to sea level. All right, so what I want to point out here are these elongated, light-colored features in the peninsular Florida. So, for example, here's the Brooksville Ridge, here's the DeLand Ridge, and here's the Lake Wales Ridge. These are important recharge areas to the Florida aquifer system. These are uplands, typically sandy, typically extremely permeable sands that can absorb and transmit large amounts of water. Now I want to introduce you to a concept that some people have a tough time wrapping their minds around. Now, what we're looking at here are the locations of a lot of big springs in Florida, but we're going to talk about Silver Springs in particular. Okay, here's Silver Springs right here. What these lines are around Silver Springs are what's called as, the outermost one's called its spring shed. What is a spring shed? It's analogous to a watershed, but in this case, it pertains to water that goes underground and comes back out at exact same spring. So everything inside this outermost solid black line is the spring shed of Silver Springs. It is the Silver Springs spring shed. The Water Management District did some modeling, some very sophisticated modeling, and they actually also were able to plot averages transit times for water in the aquifer from different distances. So, for example, this line here inside the spring shed, so it's again water going to Silver Springs, that is the 100-year capture zone. 100-year capture zone. So from, yeah, there you go. If you If water percolated down at that point in the spring shed, it took about 100 years to get to the spring shed. It'd be to the spring from that boundary there. Inside that, there's another one, which is the 10-year capture zone right here. I'll let my associate delineate in much more visible manner. So that's the 10-year capture zone. So it's still fairly far away from where Silver Springs is. The capture zone means that if it falls on the line itself, that's how long it takes to get to the spring. So this one, the outer one, is the 100-year capture zone here. But anything inside that loop of that capture zone takes less than 100 years until you get, and we can then next define it at the 10-year capture zone. So you can see there's a steep gradient from 100 years to 10 years. Basically, the flow is getting faster and faster as it gets closer to the spring. Okay. And we're looking at a digital elevation model here, where sort of the browns are the uplands, and the greens are the lower elevations here. So all of these brown areas are basically recharge areas. Right? Here's a big recharge area for these springs over here: Alexander, Juniper, Silver Glen, Salt Springs, and Marion Blue Spring. Anybody ever heard of Marion Blue Spring? You have? Does it flow? Do you know if it flows? It does flow every 3 to 4 years when the state of Florida draws down the water level behind the Rodman Dam and takes the head off of it, and it comes back to life. There's a number of those springs, but I'm not showing them all. Here's another look at kind of the same information. 5 large springs here: Silver Glen, Alexander, Volusia Blue, and Wekiva. Each of these are located where a recharge area is immediately adjacent to a discharge area. So notice these are along the river here, and so it's not terribly surprising. Here's Wekiva, where there's all the green is a recharge area, and the white shade is discharge area. In each and every case, so recharge area next to a discharge area. Why does spring flow vary over the short term? So when I say short term, I'm meaning seasonal, year to year, or even maybe some short multi-year periods of time. And this is not rocket science. We have seasonal variation in our rainfall. This is Gainesville, and it just shows us month by month how much rain it falls in inches per month, right? And everybody knows it rains more in the summertime, right? Tropical storm season too. So June, July, August are the times where we get the most rain, and the other parts of the year a little bit less. So that is an influence on it. Turns out, though, that the actual timing of peak rainfall and peak spring discharge are not exactly the same. So, for example, for Volusia Blue, I believe its peak discharge is back in around October, and so this is when Blue Spring is typically at its highest discharge from the rain that's fallen in the months before. It takes a little bit of time for the heads to build up and and the water to move. Here's Gainesville. Rains fall for 116 years. Notice that we've had some dry years and some very wet years. So these are just simple changes in rainfall. Here's our mean rainfall, which is 50.52 inches, at least when I last calculated it. I think I have something more recent, but I don't think it's budged much from this 50.52 line. You'll notice there's some really wet years, and we have some pretty dry years here. So anytime that we get several dry years in a row, that can really show up in our springs as lower discharge, lower flow. All right, why is spring flow declining over the long term? It's not rocket science. It's one thing only. People are speculating that climate change is going to have an effect. However, it's still not completely clear what climate change is going to look like in Florida. There's estimates for more rain, there's estimates for less rain. And the latest thing I read just like a week ago is that we can expect to have wetter wet periods and drier dry periods. I was at a scientific publication. So but it's groundwater pumping is why our springs are declining. It's groundwater pumping. Instead of it going to the springs, it's coming to our wells. That's what's happening. It's been doing that ever since we started pumping groundwater early in the 20th century. Now you have to bear with me a little bit on this graphic. It's something I put together right around the time that the St. Johns River Water Management District was contemplating issuing a permit for a lot of water near Silver Springs. When I was still working for the Water Management District up into 2015, in particular in 2014, this particular gentleman permit application was denied, at least for what he wanted the amount he wanted. He said he wanted to grow some cattle on his lands north of Silver Springs. And cattle don't take that much water. He said he wanted as much water as the city of Gainesville uses to water his cattle. Well, when the permitter showed me that permit application, it was hysterical. I just burst out laughing. I said, you made that up. That's not really true. He goes, no, that's what he's asking for. And originally, he got denied that amount, again, while I was still there. Shortly after I was no longer working at the Water Management District, I think he did get a permit, but he never built what he really was going to do. Everybody knew he wasn't going to grow cattle. He was going to grow rooftops. That was the thing. Anyway, there's a story in this graphic. When the Water Management District did a 180, turned around about face, and said there was enough water, there isn't a problem with Silver Springs, they released some information that darn near made me pass out. It was so false. So let me explain this to you. This is the Silver River mean daily discharge from 1935 to 2017, and it's from the United States Geological Survey. So you can bet your sweet bippy, it's good data. All right, so from 1935 to 1970, here's the mean. This is the actual data from the USGS in the blue lines. So you can see there's a lot of variation. I just plotted the mean on there for that period of time. Likewise, from 71 to 2005, I calculated the mean and drew it on there to show you the mean for that period of time. Again, lots of variation year to year due to short-term variations. And then from 2006 to 2017, here's the mean here. Now, I think nobody would disagree that spring flow was declining in Silver River, right? That's obvious. But when the district wanted to issue that permit, it said that the decline in the flow of the Silver River was only a tiny little bit below what it was originally when we first started getting data. And they said the number, and I wrote down the number, and here's the number they came up with, right? And it was like so absurdly inaccurate, but most people aren't going to know the difference, unless you're a nerdy hydrologist like me, you're not going to know. They got away with it. They got away with it. So the moral of the story is, even in Florida, the state with the best statutory and administrative frameworks of law in the country, best water law in the country, this kind of shenanigans goes on. And we gotta have a citizenry watching out what our government does. Here's public water supply, freshwater withdrawals from 1950, going up to 2010. We don't use a lot of surface water. Mostly we use groundwater, but they're both shown here, and in increments of 5 years. Notice the increase in our public water supply freshwater withdrawals. This is not rocket science. Anybody who retires in New York, in that particular area, where do they want to come to retire? Well, it's not in New York or New England. Most of our growth is retirees coming out of the Northeast. So that's why it's going up. Population growth largely. At one time, I haven't checked it recently, 1,000 people a day were coming to Florida, not to visit, to live here. 1,000 a day. Fortunately, because we're an old state, our fertility rates aren't especially high. So that's somewhat of a counterbalance. So here's a graph that takes estimates of population from very early times here in Florida, up until the modern day where it's actually been measured, in the 20th century and beyond. And I don't have the latest data, but these are projections that I think came from IFAS at the University of Florida. So they're good projections. And I think they're a little low at the moment, but 26.1 million in 2040. So population is growing. Our demand for water is growing faster than we're conserving it. We're going to be adversely impacting our springs more and more and more every year unless we collectively decide to do something about it. This one's not rocket science either. Why is spring water quality decreasing? Well, obviously, we haven't had a perfect record dealing with our wastewater. So septic tanks and reclaimed water at land surface, we're doing better now. We are doing better than in the past. But we have a legacy of nutrients that got into the groundwater, and there's still some coming in places. Even today, when a land developer comes to Florida, and wants to develop some land to put rooftops on, right? They don't always put in a public water supply system and a public water treatment system for wastewater treatment. Often what they do is they have individual wells and septic systems. Well, I don't know if you've ever had a septic system. I have. Some are good, some are so-so, and some are terrible. And they all need to be maintained. Not everybody who has a septic system knows that they need to have their tank pumped out from time to time, and they need to have their drain field looked at too. So they can be a bit of a problem. Of course, we still have a little bit of a problem with fertilizers, ag and residential. Ag has gotten better. They really have been getting better. But again, we have a legacy of nutrients in the Florida aquifer system that is still coming out. So whether or not we'll get that under control or not, I don't know. In some of the springs, the nitrate levels are still rising, and that is very, very troubling. So again, fertilizers, I don't even need to. I mean, you know, we can grow Florida-friendly landscapes and you know, and don't even need to water or put any fertilizer on it. And then, of course, increased pumping of groundwater is doing something from below. So that lower Florida aquifer is pretty salty. And if you look at records for the big public water supply wells that are pumped around the state, from, say, Orlando north, what you'll notice with all of them is they get saltier and saltier and saltier through time because they're pumping up water from below that's saltier. And ultimately what they'll do is they'll abandon that well. They'll just plug it, and they'll drill another well maybe a mile away and start fresh there. But again, the same process occurs, pumping that salt water up from below. So that is a threat, not of nutrient contamination, it's a threat of salinity. Yes, we could deal with it by desalination, still pretty expensive. And I think, oh yeah, I wanted to show you the salinity. It's kind of hard to see it in this particular illumination. But, these are lines showing equal thickness of the Florida aquifer system at 100 feet. And we can't really see the colors, but in portions of the aquifer system, it's very, very salty. So the darker blue contains water with less than 10,000 milligrams per liter. But remember, that's 10 times too high to drink. And then the other color, it's kind of hard to see here, is more along the peripheries of the peninsula. And that's water that has more than 10,000 milligrams per liter. None of that is drinkable. That's getting close to what seawater is. And so we're pumping salt water up, and that is a big challenge for Florida. And that's it. And I suppose we have time for questions.
Questions? That gentleman back there, let me know. Coming around. I always visualize the Florida aquifer as a big sponge, which has sometimes big holes in it that the water flows through.
That's Larry Lowenthal. The holes are not my fault. Okay. Is there a correlation between the spring flows, elevation, permeability, and sinkholes in Florida?
Yep, sure
Could you
are.
explain that?
So we're talking about the intrinsic permeability of the Florida aquifer system is because it is largely dissolved away in certain places. The things we see are caves above ground, like in peninsular Florida, and then below ground, those underground caves. Those are all caused by basically the aquifer over a long period of time, it dissolves away. And those things, when that happens at the surface of the land, those things can produce sinkholes by different mechanisms. But the most dangerous ones are the sudden collapse ones, where it just boom and drops down into the void in the aquifer, that limestone that's dissolved away. And so those are dangerous. Others are just subsidence ones that are not so dangerous. But yeah, sinkholes and the Florida aquifer system are intimately linked together.
Rainwater is slightly acidic, so it tends to dissolve the carbonate geology of Florida. So that's why we get some of these. We have caverns limitless to man. Well, cave divers come from all over the world to dive in our North Florida caves. Cave springs, they go down through the springs and they go for miles underground through these. And there are videos which were made by Wes Giles years ago that I would love to show, but I don't know where to get them.
From Tess Giles, from his daughter, Tess.
I have a question about desalinization. And, obviously you could think about in Tampa, you could use some of the bay water, which is obviously higher salt, or you could go down to the brackish system in the ground. And I'm kind of interested in why wouldn't desalination plants be close to where there is less salt in the water, in other words, brackishness. And I'm kind of curious about where would be the best places to place the desalinization plants if we have to resort to that?
That's a good question. Well, we could basically tap the saltier layers at depth in the Florida aquifer system anywhere, although it's less salty in the north than in the south. There are some challenges about what to do with that brine that's the waste product. If you're inland, you're not going to be putting it out in the ocean, the long pipeline, but it could be pumped down deep into the bottom of the lower Florida and disposed of there. What's the long-term prognosis for that? Well, it's going to get saltier and saltier. And again, it'll move up where there's wells pumping. It'll tend to move back up again. But I don't think that's a short-term problem.
There is a desal plant in Tampa operating. It's extremely expensive. In 1995, we estimated the cost at $5 per 1,000 gallons for the desal water. The problem is the high energy requirement for the reverse osmosis system. To my knowledge, that's the only desal plant in Florida.
Well, there's one it was built a long, long time ago down in Key West for the Navy.
Yeah.
And I think I had heard they actually fired it up and were using it a little bit down there, but I don't.
But the brine, the waste product is defined as an industrial hazardous waste. So it's subject to all sorts of requirements for disposal.
Jim, I wanted to ask a permitting question that sort of relates to the water being essentially free. Do I understand correctly that if somebody wanted a permit, certainly a home permit to drill a well, I could pump as much water as I want? And for a large permit, you mentioned the development that might want to build several houses. To put it in a well and get a supply of water, it's my understanding it costs about $150, and then you can pump, I don't know how much water, a lot of water. So in Florida, water is essentially free. I mean, that seems like a major problem. If you would address that.
Well, that's true. You know, we don't pay for water unless we are in a metropolitan area we have a water company, a utility that pumps the water out, treats it, and delivers it to our house. But theoretically, we're not paying for the water, we're paying for the service to get it into our faucets, right? Florida is very different from other places in many respects in its water law. I'm sure you know that. I don't know that we can necessarily do a lot to put in price signals into the water, but there's talk about doing that, about having charges on water, surcharges, to pay for the infrastructure that's needed statewide. So that might be something that might, you know, be a conservation rate structure type of thing, which we do see in Florida to incentivize less water.
I'll be talking about Florida water law in my presentation on April 4th. We have a question online from our Zoom audience. I don't see a hand. Oh, okay. Would removing Rodman Dam improve the quality of the springs?
Removing Rodman Dam, or Kirkpatrick Dam as it's officially called these days, would certainly improve the water quality in the Ocklawaha River and restore flow of springs that are now not flowing at all. We know that's the case. Lots of studies have looked at this. And so, you know, when the dam is up at full level, you know, water's actually going from the reservoir down into some of those springs, particularly the ones that are close to the dam. And then when they draw the water level down, those springs begin to flow. Restoring the Ocklawaha River would bring an increase of fresh water into the Ocklawaha River, which would be good for the whole system, the Ocklawaha St. Johns River system, because it's a tributary to the St. Johns, the lower St. Johns River.
Yeah, I just wanted to mention that if people want to see solution sinkholes, we've got plenty on the property. Just take the woods road or the path through the woods, and you can see these holes. I think that's how we put the driveway where it is. We have that easy geology here, but further north, why, that's where the bad sinkholes happen. How come?
Well, there's different kinds of sinkholes. Where most of the unconsolidated deposits above the limestone are sandy, they tend to just, when it starts dissolving a cavity below, the sand just kind of, filters down slowly with it, and you get kind of this, very slow sinkhole development. But if the sediments overlying the rock, the limestone rock, are not sands, they're clays that are very cohesive, what can happen is they don't make it all the way to the surface. So there's an undermining of that clay layer that begins to fall in from the bottom of that clay layer, falling into that void in the limestone. And the cohesive material on top gets thinner and thinner and thinner until boom, it blows. And that's what's called a sudden collapse sinkhole, like the one in Winter Springs some years ago and others like that. That one down in Southwest Florida, I don't know, maybe 10 years ago, where the guy's house fell into it and he was never seen again. His brother, I think, heard him calling out, ran to find him. By the time he got there, he couldn't be heard, couldn't be seen. Sudden collapse.
Yeah, I remember reading that.
Yeah.
just
Scary.
in the middle of the night.
Yeah.
Yeah, and he's gone forever. They couldn't find his body.
Wasn't that the Winter Springs one? I think it was, yeah. I remember seeing the Porsches in the hole. I think they got some of them out.
Can I return to the Rodman Dam again?
Of course.
Given the current political climate, do you anticipate any action on that? By action, I mean, do you see any action of it being removed, or is it a woke?
That's a very good question to ask. What is the status of movement to restore a free-flowing Ocklawaha River? It's been dammed now for, what, 54 years or so? We have been reaching out, FDE, but also in our coalition of partners that we brought together that we're working with on a day-to-day, week-to-week basis, looking for ways to communicate to legislators and to the governor's office what's going on and why that river should be restored. You know, the arguments haven't changed much over time. Not only will it be good for the hydrology, it'll be good for the critters as well. I mean, manatees need to get back upstream for warm water refuge. They're losing those once through cooling power plants progressively over time. They need more springs. They also need fresh, clean water so that they can have seagrasses to eat, and that's a problem too. And those free-flowing Ocklawaha River would be not only opportunities for feeding, but it would also be an opportunity for thermal refuge during the cold winter months. So there's lots of reasons to argue that this still needs to be done, but we have not seen. And we even had a delegation go up and talk to the governor, and that didn't turn out the way we wanted it to. He agreed to meet with a delegation, but in the morning he had flown to another location for a meeting, and the story we got told, which sounded plausible given the weather, was he couldn't get back in the sky with that small plane because it was, a thunderstorm. And so we met with his staff. I say we, I wasn't at the meeting, but several other people were, and his chief of staff was there. His attorney was there. And so we also sent some various other people up on this, people who were interested in the aspects having to do with fishing, both commercial and recreational fishing. And they spoke also in favor of this. And we thought that was important because the main opposition to restoring the river comes from a small group of people who fish upstream of the dam, who say they like it the way it is. And they have been, to their credit, successful for years and years, decades, at keeping things in the status quo. But the fact is, there would be even bigger fish coming up that river, like striped bass, if the dam comes down. We have not. Here's what I'm going to say, representing me. It's been very disappointing to see the lack of engagement of legislators, state legislators, and the governor on this topic. I don't know if you noticed that the organization called Florida Tax Watch, which tends to be a little on the conservative side, they came out vigorously advocating restoring the Ocklawaha River because it made economic sense. But they also said it made environmental sense and all these other things, that it made sense to do this. And they encouraged the governor to move forward. The governor has still yet to show any indication of interest in this particular subject. So So we're very disappointed in our state government.
Oh, there are a number of questions from the Zoom audience. Not sure if you have time, but I'm curious about sinks. Are they opposite of springs? And how do they affect the springs, if at all?
Sinks. That the question about sinkholes?
Yeah.
They're-
Are they
they're-
the
they're
opposite of
related.
springs?
No, sinkholes typically aren't springs. Typically not. No.
Sinks as in the Alachua sink.
They don't give, they take.
It's my understanding, and correct me perhaps, that sinkholes happen more frequently in drought, when drought periods are ending, because during a drought, of course, there's less water supporting the lime rock structure, this very porous lime rock structure. There's less pressure supporting the stones and the layers of limestone. And then when it starts to rain again, there's this dissolution. The rock is dissolving and it collapses. Is this approximately correct?
Yeah, when the water levels are up, to some extent, it's like, floating in water, there's less support if it's dry than if there's water there. So yes, when the water levels are going down, there's a kind of a correlation there that you may tend to have more sinkholes right there in that time. It's not the primary factor.
So Julianne thinks that one of the questions pertain to the Payne's Prairie. Sinks like Alachua Sink in Payne's Prairie. Okay, is that the opposite of a spring? Well, it's a sinkhole that has a direct connection where.
Yeah, sink is the opposite of a spring.
Okay.
Where surface water goes underground into the aquifer.
Okay.
Yes. Yeah, well, a lot of that has to do with how high the river level is. High levels, it's going in. Low levels,
Yeah.
I got that backwards. Yeah, high levels of water is going into there, and then at low levels of the river, the springs flow.
Yeah, I recall time we had a lot of rain that was coming our way. Maybe it was a river of rain then, in the 90s, I guess it was, or late 80s. And the sinkholes became springs, that the water level had gotten above the level of the soil around it. So the water started flowing out of the sinks,
Surface water.
small sinks.
Yeah, surface water is the first thing to disappear when it gets dry.
Well, we're over 11 o'clock, so I just wanted to let you know that our next speaker next Tuesday is Dr. Robert Knight from Florida Springs Institute. Dr. Knight recently had knee surgery, which is not progressing as rapidly as he had hoped. So he's going to be talking to us via Zoom next week, excuse me. Didn't sleep well last night. I was so excited about having this program start. So thank you very much, Jim, for.
Pleasure.
Yeah.
All right.